Okay, hello everyone. All right. Okay, so today we will do a bit of revision, okay, for paper 3. Yes, sorry, tomorrow, right? For the Amali paper for tomorrow. Okay, so actually this one I got one set. Oh yes. Good afternoon. All right, good afternoon. Okay, all right. So let's see. Okay. Um okay. So this is a sample. I think also you also got one. I think like other two teachers give you another set of question, right, for the amali, the example question. Okay, but I only take one. Okay, so for refraction. Okay, so for refraction. Okay, so I give you already like three videos for you to see if let's say come out for the total internal reflection. So usually for the total internal reflection, all right, what you need to know the formula. Okay, the formula to find the the refractive index for the total internal reflection, which is n is equals to 1 over sine c. Okay, okay. Sekejap Hello. Ya, Cik Faizal. Saya saya tengah buat kelas dengan pelajar. Tengah buat tengah. Okey. Okey. Okay, alright. So, here, alright, the question asks you, okay, just now I told you about the total internal reflection, right? So, what can possibly be asked, right? So, usually for total internal reflection, we cannot do a graph, okay? It's usually for total internal reflection, then we ask you to draw, to find the value of n, you find the value of the refractive index. Okay, find the value of the refractive index. Okay, so that means n is equals to 1 over sine c. Okay, what's wrong with the wait transparency? No. I can see. Hmm. Hmm. Okay. Right. So n is equals to 1 over sine c. So this one is for total internal reflection. So what you have to do, you have to find, okay, you have to move, all right, the laser here, okay. You move the laser here until you can see all the incident ray, okay, reflected back. Okay. But this one you have to make sure that your laser, okay, from the glass to the air. Okay. So you have to make sure that your laser is from the glass to the air, because there are two conditions for the total internal reflection. Yeah. So the first one, the light must be travel from the dense to the less dense, and the second one, your eye must be bigger than C. Okay. So if you find the light ray, okay, when it's already reflected back, so mean that it's occur already total internal reflection. Okay. So that one is for total internal reflection. There's possibly no graph you can draw based on that. Just find the value of the refractive index. Okay. Based on the critical angle. Okay. So that is for total internal reflection. Okay. Then another one is a reflection. Okay. So for a reflection. So my guess, okay, I'm not sure, right? My guess maybe, okay, the one that will be come out is a refraction. Okay, refraction. Okay, so but anyway, you have to be prepared. Okay, you have to be prepared. Okay, if let's say come up another two experiment, that is a total internal reflection or reflection. Okay, all right. So for this one, okay, um, So this is the question. Okay, let's say this is for the guided one. So for the non-guided, I think I already give you example, right? For the unguided. Okay, so this is the example, the question for the unguided. Okay, so they give you a situation, okay, and you have to write the inference. Okay, so this one I will teach you later. Okay, but now we're going to the guided first. Okay, so the first one, so this is the a student carries out experiment to study the relationship between the angle of incidence and angle of refractions. So the angle of the incidence, okay, this is the I, okay, and angle of refraction, this is R. So means these two can be the manipulated or responding, okay, can be the manipulated or responding. So how do we know which one is the manipulated and which one is the responding? Okay, that one we have to see, okay, the question, okay, what is the value that be changed, okay, when you do the experiment, okay. So now this we didn't use a ray box, we use a laser, okay, and of course we use a protector. Okay, so this one I already give the answer. Okay, I already calculate the answer. Okay, but then for this one, let's say you already done all the experiment, right? And remember, you are doing it in the F4 paper, right? So make sure you do make sure you do it. I mean, because I know, right? Some of you memorize the answer, right? But be careful because in case, right, they ask you to submit also the F4, the one that you draw in the F4 paper. They ask you to submit, okay, with the with the A4 paper, so the one that you draw all the refracted ray, right? So be careful, okay? So this one you have to draw. So this is the example I already give you. Okay, so how you want to write? The first one is sin I. Okay, this one you just use your calculator. So how many decimal? It should be 2 decimal point until 4 decimal point. Okay, but for me, I advise to you, okay, because every year they change the way they're marking, right? So you put three decimal point. Okay. But then when you draw the graph, you can round off it with 2 decimal point. Okay. And the value of R, okay, remember it must from the normal line, okay, normal line to the refracted ray. So this is a refracted angle, right? So this is your refracted angle. So some of you ask me, okay, is it need to be a dotted lines? No. Okay, you can just draw a straight line. No need to be dotted as long there is a normal line. Okay, then you give the answer sin R. Okay, use your calculator. Okay, do you got the answer? Okay, then you continue. Okay, let's say for this one. Okay, so sin 30 is 0.5, correct? Okay, but you already start with 3 decimal point. So all of it must be in 3 decimal point. Okay, so you start with 3 decimal points, so all of it must be 3 decimal point. Even your answer is 0.5, only 1 decimal point, so you add 2 more zeros, so it can become 3 decimal point. Alright, so this one I already write the answer for you. Okay, so remember there's no unit for sin I and sin R. Okay, no unit. I know in the video they put a unit for sin I and sin R, right? No unit for sin I and sin R. Only I and R only got unit. Okay, so be careful. Okay, so this is the refracted angle. So you just read the protector. Okay, so we move to the manipulated variable. So this one, okay, we want to find what is the refracted angle. So okay, what is the manipulated variable here? So according to the diagram given, right? According to the diagram given, you see what is the value that the question gives to you. They give you the value of I, right? They give you the value of I. So means, okay, during the experiment, the I value is changed. So that one is the manipulated. Okay, so based in the sentence here, it says angle of incidence I and angle of refraction R. So means angle of incidence I, okay, so I means this one, right? This one that changed, okay? So throughout the experiment, this one is the one that changed. So the manipulated, okay, the manipulated is the angle of incidence. teacher, do I need to put a symbol? If you want to put, you can put. If you don't put also, you can still get a mark. Okay. And your responding variable. So if your angle of incidence uh, is the manipulated variable, so means the angle of refraction will become your responding variable. Okay, will become a responding variable. So you put here your angle of refraction. Okay. This is the problem. Okay. When it comes to the constant variable, some of you will put type of light. Don't use the word type. Okay. Type of protector. Okay. Type of ruler. Okay. No. Don't use the word type. So what can we use as the constant variable here? Okay. So you can use this one because they use a what? A glass, a semicircular glass block, right? So you can say here, all right, the index, okay, the refractive index for the semicircular glass block. Okay, the refractive index for the semicircular glass block. Okay, that one will be constant. Okay, so this one, index of refraction of glass, semicircular glass block. Okay. So let's say if you have a question, all right, if you have a question, okay, you can just raise up your hand, or you just put this one, okay, raise hand. So I will listen lah, okay, because I will not see the chat, okay. All right, so we go to the next part, okay. So it says here for this part, write your question. So this one we already answer. Record the reading for the R, and then calculate the record value of sine R, calculate sine R, okay. This one we already done, okay. We already fill the blanks there. But now let's see for the for your table, okay. For your table, okay, remember must have symbol unit, okay. And then this one also symbol unit. Okay, sine R got no unit. So sine R got no unit. Okay, and remember if they said, okay, this one they're missing something here. It's supposed to be R also have to be stated here. Okay, so if you see only 3 column, right? I, sine I, and sine R. Okay, but actually you need to put the value of R also there. Okay, so you see the question there. If they ask you to put 4 value, let's say I, sine R, means you need to have 4 column. That's the first mark. Okay, then the symbol and the unit. Okay, then this one you only copy back from the diagram, right? You just copy back from the diagram. Remember, check, all right? Check your decimal point. Is it same? Okay, it's not like the whole table must be in 3 decimal point. Okay, it means you have to see it by column. But this one, because sine I and sine R is the same, right? It's a value of sine. So we take 3. So this one also have to be 3. This one also have to be 3. Okay. And for those who, like, let's say you read the protector, right? Okay. When you read the protector, suddenly your line is between, okay, is between these 2 lines. Let's say this is 25 and 26, right? So it's on the middle between 25 and 26. So which one you should take? Okay. Don't put 25.5. Okay, don't put 25.5 because your protector is only, what is the accuracy? Only is 1 degree, right? So your accuracy is 1 degree. So how can you can be like 0.5? Right. So what you have to do, you have to take the value before. So me it's not reached 26 yet, right? So you take 25. Okay. So remember that. Let's say when you draw, this one is okay because the diagram is already given to you. But then your later you have to draw on your own, right? So let's say when you put your protector, then it's on the middle between 25 and 26. So what you should put, don't put 25.5, okay? Put 25 because it's not reached 26 yet. Okay, all right. So Then after that, okay, that you put the value, okay, then complete. And table means it's table, okay. Don't put, let's say like this, as I, okay, you put the value here, sin I, you put the value here, R, you put your value here, and then you put this one, okay, diagram 1, okay, and sin R is value here, okay, then this is for diagram 1. Okay, diagram 2, okay, I is what, sin I is what, okay, like you do on your trial. Some of you did that. No. When you say tabulate, means you need to have the table. Okay, you need to have a table. So please do like this. Tables mean tables, not this one. Okay. All right. So the next part, okay, you already draw, you already have your value there. Okay, now they ask you to plot the graph. Okay. So when you plot the graph, remember it's only graph of y against x. So means in front is y, means it will be on your y axis, and this one will be on your x axis. Okay. So some question they ask you to plot sine r against sine I. Some question they ask you to plot sine I against sine r. So just remember it have to be graph of y axis against x-axis. So whoever in front it, that one will should be the y-axis. Okay. So that is how you want to find which one is y-axis and x-axis. Okay. Then we try to draw the graph. So this one I already draw for you. Okay. So let's see here. This is your y-axis, right? Okay. Then the scale. Okay. The scale. So for the scale, remember I said use a multiplication of 1, 2 or 5. So what does it mean? Whether you can use 0 0.1, 0 0.2, 0 0.3, 0 0.4, 0 0.5, okay, and so on. Or you can use 0 0.2, 0 0.4, 0 0.6, 0 0.8, 1.0, okay, that one. Or you can put 0 0.5, 1.0, 1.5. But remember, you have to use half than your graph paper. Okay, half than your graph paper. So make sure you choose a right scale. So remember 1, 2, 5 only. Don't use other than that. Okay, multiplication of 1, 2 and 5 only. Okay, so this one I already draw. Okay, so for your axis, it must have a label. Teacher, where to got the label? You see your table here. Okay, so since there is no unit here, so means you only got the title of the axis. Okay, but let's say they got the unit. Okay, let's say they ask you to plot I and R, right? So I against R. So I got unit degree. So means here you have to put I plus degree. Okay, I slash degree. Okay, must have symbol and unit. But for sine I, because they don't have unit, so you just put the title there, sine I. Okay, and this one, of course, the axis, the x-axis, okay, sine R. If you got unit, then you need to put slash the unit. Okay, then after that, you plot. Okay, so remember we take 3 decimal point, right? So it's hard for you to draw, let's say for 3 decimal point. So what you have to do, you can round off it to 2 decimal point. So it's much easier. Okay, so in the graph, you can round off it to 2 decimal point. Okay, but in your reading, you put 3. Okay, then after that, you plot the graph. Okay, then next part, you need to underline. Okay, remember bring the long ruler. Okay, don't use a short ruler. Okay, use your long ruler. Okay, yeah, 30 cm one. Okay, not 15. Okay, then when you plot, okay, so you need to find, okay, this is the important part. Okay, I asked my friend, okay, dia ketua pemeriksa lah. So I asked about the graph, right? So because some of you got info, okay, we need to make sure that it's passed through the origin, right? And some said no need as long as best straight fit. The line is the best straight fit line lah. Okay, so what is it is actually, okay, you have to find the important part is your line must be in the best fit. What do I mean by best fit? I teach you already, right? 2 at this part and 1 at this part. Or you can change 2 at this part, 2 point at this part and 1 at this part. Or 1, 1. Okay? 2 at this side, 2 at this side, 1 at this side, or 2 at this side, 1 at this side, or 1, 1. But remember, the line, the point that you draw, you plot must not more than 0.5 cm. Okay, so from the line you draw and the point that you cannot touch the point, right? The point that you cannot touch, okay, the distance, okay, must be less than 0.5. Okay, so you need to measure lah. So this one you just measure it like this. Okay, from here to here. Okay, it's not from here to here. Okay, it has to be this one. Okay, like this. You measure how many cm. It's more than 0.5 means you need to find another line. Okay, so it can be. Then when you draw, let's say, okay, like mine, right? You can see it's not passed through the origin. Okay, but we learned that the Snello state, okay, sorry, that the sine I is directly proportional with the sine R, right? Okay, so but we cannot get in the graph, right? Directly proportional. So it's okay. You can put the graph increasing linearly. Okay, so it doesn't have to follow the law. Okay, because the question asks you, right, based on your graph, means what graph that you get. If you get directly proportional, means that's good. Okay, let's say you try, you cannot find the best straight line. Okay, then you have your graph is like mine. Okay, so this one is not directly proportional. So this one increasing linearly. So when I answer the question, you can put increasing linearly. Okay, just put it like that. Okay, increasing linearly. Okay, so let's say here also increasing linearly. Okay, so if only in the origin, okay, between this one small box, that one is a directly proportional. Okay, but for me, if you don't just simply adjust the reading, because of what? Because you need later when they ask you to submit the A4 paper and the pemeriksa, you know, like measure the your angle is not same like what you got in the answer, then it's quite, you know, like quite trouble lah. Okay, so just do like, okay, like just be try lah. Okay, try to get the good answer. Okay, when doing the experiment tomorrow. Okay, so that is the how you want to draw, okay, for the graph. So remember, axis must be level, scale must be start from, it must be uniform. Cannot this one 0.1, 0.2, suddenly this one 0.4, 0.7. No, okay, it has to be uniform. Okay, so you just do it like that. Okay, so your scale must be uniform. Okay, so this one also must be same. You want to put here 0.2, then suddenly 0.3 here. Cannot, must be, if you start 0.2, 0.3 means 0.1 you have to write also. Even there is no reading for 0.1. Okay, so your scale must be uniform. Okay, that's for the graph. Okay, the best straight line. Okay, so I think wait, I check the schema first. Okay, so you already graph size. Okay, size of graph already told you. I already told you how to balance the graph, the scale, this unit. Okay, done. Okay, now we are going to the question part. Okay, so of course they will ask you to find the gradient. Okay, of course. So you know when I'm marking your paper for the trial, okay, I think like 90%, okay, you don't know how to draw the triangle. You draw the triangle, but the triangle is not big enough. Okay, so I will use this question, okay, this question as an example. Let's say this is the graph that you draw. Okay, and the first one, they ask you to do what? State the relationship sine R and sine I. So of course you can see it's passed through the origin. So this one is a directly proportional. Directly proportional. Okay, and this part, determine the value of I when sine R is 0.6. Okay, your sine R 0.6. Okay, make sure you underline. Show in your graph. Underline it. Okay, then go down.
Sure. Can you use dotted lines?
Yes, you can. For me, just use the normal line because your answer will be scanned, right? You have to scan the answer. So I'm afraid that maybe the pemeriksa cannot see it very clearly. Use a line. No need to use a dotted line. Okay. Alright. So you just underline like this, then you go down here. Alright. This is 1 mark. Okay. They got mark for this. Then you read what is the value here? 0.9. Okay. But the question, see the question, it says determine the value of I when the sign R is 0.6. Okay, your value of I is actually what? Sin I, right? 0.9. So means you need to do the inverse. So be careful what the value that they want. Okay, is it I, sin I? If sin I, you can just put 0.9, but that one is I. So I must be in degree. So you put sine inverse of 0.9 here. So shift, okay, shift 0.9. Okay. Uh-huh. You got 64.16. Okay. So take 2 decimal point, please. Okay. And no fraction. Please, no, don't do fraction anymore. Okay. I know for sign, of course lah, no fraction, right? But later paper 2, you put fraction. Don't use a fraction. Okay, 64.16 degree. So that's the answer. Okay, so you can see 3 marks. 1 mark from the graph. Second mark is the calculation here. Third mark come from here. Okay, but then the next part, calculate the gradient M. This one, okay, luckily if you got like sin I and sin R, of course there will be no unit. Okay, okay, there will be no unit lah because sin I no unit, right? Because Y divide by X, right? Okay, so let's try to put the 1, 2, this is the formula. Okay, I think you already know. Okay, now when they say a gradient must have a triangle. Teacher, how big is the triangle? Okay, what is the minimum? Okay, minimum size. So what I suggest you to do, okay, let's say if your graph pass through the origin, you take the first point here. This one will be xy, y1. Okay, take from the origin. Okay, but let's say teacher, my graph not passing through the origin, like mine now, right? So you take here. Yeah, take here. Okay, then this one should be xy, y1. Okay, so where does the graph intersect? Okay, at y-axis or x-axis, that one should be xy, y1. Okay, so this one you already know, 0, 0, correct? Okay, then the next part, teacher, where I can find the next point? Okay, so yeah, it have to be 4 times 5 or 5 times 4. What does it mean 4 times 5 and 5 times 4? Okay, 4 means this one box. 1, 2, 3, 4. Okay, so let's see if I took this point because we already read the point here, right? So this one should be 0.9, 0.6. Okay, so if I take this one, this point that you already put the line here when you find the value, right? So we take this one. So you see with the graph, is it enough? 1, 2, 3, 4. Okay, this one, is it enough 5? 1, 2, 3, 4, 5, 5, 6, right? So it's more than enough. This is the minimum. Teacher, if I want to make it more bigger, I want to take until here. Okay, until here. So 0, 0, and this is the point that you want to take. So then you can use that one. But the minimum must be 4 times 5. Okay. Okay. And what does it mean by 5 times 4? 5 times 4 means this one 5, this one 4. Okay. So you can use either one of this. Okay. So for this is the size. So because when I mark your exam paper on trial, yeah, you do a triangle. You have a triangle, but your triangle is too small. So you lost 1 mark here. Okay. Because the size of triangle is you can get 1 mark from here. So let's say you take this one and this one, okay, so you can get 1 mark because your size, the triangle size is bigger, right? It's more than 4 times 5, okay? So, okay, so 1 mark from this one, okay? And the second mark, okay, we replace the value here. Okay, so I think 0.9 0.9, right? Yeah, 0.9, 0.9, 0.6, y2, right, 0.6 minus 0. Okay, 0.6 minus 0, okay, divide by 0.9 minus 0. This one is, you have to be very careful. You always like to answer in fraction. I said no fraction, no fraction. Okay, so 0.67, all right? Take 2 or 3 decimal point. Okay, let's say teacher, I want to put 3, up to you. Okay, but not 1 decimal point. Okay, so if I take 3, 0.667. Okay, the unit, because you're sin I and sin R, of course there's no unit here. Okay, so when no unit here, so means you don't need to put the unit. Okay, so this is your value, 0.667. All right, 0.667. Okay, if, okay, if they got the value, I give you the example lah. Okay, but usually I don't think so, because if you divide angle also, right, they say if say I divide by R, I also degree, R also degree, you be cut, right? They say this one the unit is degree, this one divide by degree, cut, so no unit also. Okay, but let's say they give you a unit, example, okay. So let's say this is kg, this is m square. Okay, so your y-axis unit is kg and x-axis unit is m square. So your unit is kg m negative 2 or kg over m power of 2. Okay, so the y-axis unit divide by x-axis unit. Okay, then you got the answer. So you put it here. So this one got no unit. So just put that. So 1 mark from the triangle. See, 3 marks, right? 1 mark from the triangle. Second mark from the calculation. You replace it correctly. The third mark is the unit. Okay. Wrong unit means this one you lost the mark. Okay. Then next part. So it says the index of refraction N of the glass is given by the formula N is equals to 1 over M, where your M is the gradient of the graph. So calculate the value of N. So you just replace the value. You already got your M gradient is 0.667, right? So N is 1 divided by 0.667. So 1 divided by 0.667. So you will get like 1.499. If you round it off, you will get 1.5. So you put here 1.5. 1 mark here, 1 mark here. Okay, then the next they give you the relationship between the speed of light and also the speed of light in air and also speed of light in glass. So where n is the index refraction of the glass. They give you the value of C 3 times 10 power of 8. So using the formula given, the value of C and your answer in B, calculate the speed of light in glass V. So this one, N is equals to C over V. Okay, you already have your N here, right? 1.5. So you replace it here. So your C is 3 times 10 power of 8 and your V you need to find. Okay, so we just 3 exponent 8 divided by 1.5. So you will get like 2 times 10 power of 8. 1, 2, 3, 4, 5, 6, 7, 8. Yes. 2 times 10 power of 8. Okay. Okay, this one lucky they already give the unit for you. But let's say they didn't give, then you need to put on your own. Okay. Next part. One precaution. Okay. I already told you so many times. I say if they say precaution, just use this one. Just use this one. Don't use others, right? So what? Make sure your eyes, not parallel, okay? Perpendicular. Make sure your eyes perpendicular. Okay, with the scale of, okay, now what is the measuring tool that you use here? You use a protractor, right? So perpendicular with the scale of protractor, okay, to avoid parallax error. Teacher, if I spell it wrong, okay, in physics, right, if I try to pronounce, okay, the word that you spell, okay, but it almost the same. Let's say you put EA here, you put E, parallax. Okay, I still can understand you mean parallax. Okay, so you still can get the marks. Okay, but mean like don't just purposely do it lah. Okay, just spell it wrong and spell it wrongly, spell it correctly. Okay, so this is one mark. Just remember this one, please, please, please. Don't use other. Don't use repeat. No, no, no. We didn't accept the repeat your experiment. No, it's a long time ago. Okay, since I'm marking like 3-4 years ago, they didn't accept repeat anymore. So, but this one, every time I'm marking the paper, yes, this is the one that we will surely give you a marks. Okay, so but make sure you know what is the measuring tool. For of course, they give you already the protector. Okay, if ruler, yang you put ruler lah there. Okay. Alright, so that's the question. Okay, so any question you want to ask, teacher? Shape of glass block. No, no, don't use shape. Teacher, can I write incident angle? Okay, can. Shape of glass block cannot. Okay? Shape of glass block cannot. Others question you want to ask, teacher? Before I move to the non-guided. Teacher, all the lines drawn on the paper need to be labeled. Yes, need to be labeled because I'm afraid they will ask you to submit it also. Teacher, can we put the refractive or index as a constant variable? Yes, you can. Okay, I also put the refractive index. Type of no, don't use the word type. That's me. Don't use the word type. I said no, no, don't use type. Don't use type because you cannot measure type. How can we measure type? Let's say you put it type of protector. Okay, type of protector. How do we know that this is a type of protector? Do we have a type of protector? Teacher, cannot. Okay, don't use type. Right? Use the index of reflection. Yeah, why I've been asked. Virishva, teacher, how to get 50 over 50? If you follow all the one that I give you, surely you can get. Yeah, it's not possible, but usually we are careless. Okay? Remember, just do what I said just now. Okay? It's just same. Last year also, when I mark, yeah, just same one. Don't worry. Okay? But I'm not sure lah. Nanti I confident sangat cakap refraction dan later you tak sedia. Subjek yang tu untuk eksperimen lain kan, just see the three lah. Okay, because tomorrow I also will do the experiment same time as you. Okay, okay, so this is the example. Okay, so this one is a refraction experiment also, but it's unguided. Right, we don't know whether we get the guided or unguided, or maybe like some guided, some you need to write on your own, right? Okay, so luckily I get one question, okay, from the MRSM paper 3. So they give you a situation like this. This is called what I said. They give a situation, then you need to know, okay, what experiment how we have to conduct the experiment based from the item they given here. Okay, we do the refraction, right? But you see in our apparatus, we only have a few things like semicircular block. Then we have a protector, A4 paper, right? And the laser, okay? Then that is only that what we got. But here, okay, you see so many things. Teacher, why? Because they use a ray box. Okay, so inside the ray box, okay, of course, you know the ray box, of course, the light will come out from the ray box, right? So they got the menthol there, okay, and they got the, okay, they got the menthol there, then they got the dry cell. Of course, this one they use a dry cell, but normally we use a power supply, okay? But this is just, maybe 1.5, I think not that bright lah, okay? You have to close all the curtains there to make it dark, okay? Yes. Calculation for refractive index, can we use n sign depend on which y must, okay. Must use n over sine 1 over sine c. Okay, 1 over sine c is for total internal reflection only. Okay, because 1 is actually sine 90. Because when you already know, right, for the yes, is it okay? Can you understand it, Wendy? Nantilah, janganlah cepat sangat. Cikgu nak baca dulu. Okay, so remember 1 over sine c is only for total internal reflection. But for the refraction, okay, refraction must use n is equals to sine y divided by sine r. Depend on which is y and x. No, because in the table you already know your sine I and sine x, right? And actually the gradient, I forgot to mention to you. The gradient that we find here, this one, 1.5, right? The gradient that we find here, which is the gradient? Yeah, this one. The gradient is actually equals to what? Is actually equals to the refractive index. So let's say they ask you, they ask you to calculate the gradient. Then they ask you, what does it represent? Okay, what does the value that you count before the gradient? Okay, the gradient represent what? So it represent the refractive index of the glass box. Okay, refractive index of the glass box. Wendy, is it okay? Yeah, all right. Thank you. The next question. One over m. Does that mean is sine I r again? Yeah, when y over m, because your m is just now they use what? Your m is y against y divided by x, right? Sin r again divided by sin r. Okay, so bila jadi 1 over m, dia akan terbalik kan? It will become opposite. So sin I divided by sin r. Is it okay, Avinash? Because 1 over m. Alright. So the next question, which one do you use for critical angle? Okay, so for critical angle, okay, let's say you can use the semicircular glass block actually if you want to find the critical angle. Okay, but you need to make sure that your light is from this is, let's say, your laser, right? So the light will come from the dense to less dense. Okay, so let's say this is a normal line. Okay, you can see the light, okay, go into the straight line. Okay, then after that, you will increase the value, right? The angle here, the angle of angle of incident, right? So when you keep increase, okay, you can see there's some line. I think you already see the video, right? Let me open it, the video for you, because if I put it like this, it's hard for you to imagine. I think yeah, this one. Okay, so I just siapa ni? Ah, okay, so this is the basic. See, now the laser comes from the dense to the less dense. That is the first rule for the total internal reflection. Okay, the light must come from the dense to less dense. So when you point it at the normal line, you can see the line going straight, right? So you increase it. Okay. So here you can see there is some light, okay, that the light is refracted. Okay, means the refraction occur here. Okay, and at the same time you can see there's a, like not very clear, right? The line that is reflected back. Okay, but not that clear. Okay, so you keep increase the incident angle. Okay, now increase the incident angle. You can see here the line is much clearer, right? Okay, it become more clear here. The reflected ray, okay, it much clear here. Okay, but then it's still not total internal reflection yet. Okay, you increase. Okay, now, okay, you see the line, right? When the line is on the boundary from the glass block, and also let's say the line is here. Okay, wait, I put the say something that kat sini. Okay, so let's say the line here now, it here come at the boundary here. Nampak? Okay, say let's say the line is here. Okay, this is the incident angle and this is the your refracted ray. Okay, But now it cannot be refracted ray anymore lah. Okay, this is the incident angle. Your incident angle here will become your critical angle. Okay, so your I, let's say when you calculate, oh, your I is 20 degrees. So mean your C is 20 degrees. When the refracted ray on the boundary between the glass block and the air. Okay, so this is called as C. The incident angle here, we call it as C, critical angle. Okay, and they ask you, this is let's say come out paper 2 lah kan. They ask you, what does it mean by critical angle? Critical angle is when the angle of refraction is 90 degrees. See, it 90 degrees from the normal line, right? Yeah, so that is how you want to find your C. Okay, am I answering the questions? Which one do you use for critical? Yeah, the incident angle when the refracted angle is 90 degrees. Okay. Is it okay? Blue Thunder. Teacher, shouldn't the value of the refractive index always be more than 1? Yes. Okay, if you got your refractive index, okay, less than 1, means it's wrong because it should be more than 1. Okay. You see this one, isn't it? Kai, which one? I just calculate this one. Here, right? 0.67, right? Is it Kai? Yeah, okay. So, okay, that's why you can see here, they put 1 over m because now they give you the correct formula. This one is actually because if the graph sine I against sine R, okay, if your graph sine I against sine R, then your gradient is equals to the refractive index. But now your graph is sine R against sine I, so it's opposite, right? So that's why they put n is equals to 1 over m. Because if you put, let's say here I put sine R against sine I, correct? Okay, so if I put that, then it become n sine I divided by sine R. So you got the index of refraction. This is the formula, right? So that's why. Okay, yeah, if you put this way, if I put 1 over m, I can get 1.5, right? So this is the index of refraction. So you see, it's not always, let's say your graph should be sine I against sine R. So if sine R against sine I, your index of refraction is n is equals to 1 over m. Because you know that n is actually sine I divided by sine R. But now your calculation is sine R divided by sine I. So if you want to get it, opposite, okay, then you have to divide, right? 1 divide, then you go up, then you can get sine R with sine R. Okay, is it okay, Kai? Okay, then ada another question? Any other question before I move to the next one? Okay, no. Okay, so I move to this part. Okay, so this is the unguided. Okay, so I already teach you here, right? So this is actually inside the ray box. Okay, they got the menthol. Of course, the dry side is to use to switch on the ray box. Okay, and they got the battery holder. Of course, the connecting wire. Of course, to connect the ray box to the battery. Okay, and the protector. Okay, we have that one. Okay, and the plastic ruler. Okay, the plastic ruler. Maybe to measure. Of course, you need to draw all the line, right? All the line, the refracted angle, or refracted ray. So you need, of course, the ruler, okay, and also the glass block, of course, the A4 paper, and the cylinder pipe is actually inside the ray box, okay, and switch, of course, this one is to switch on or switch off, okay. So all that you can see, there's so a lot of apparatus here, okay, but actually that one is inside the ray box. So when you draw, okay, so the question, this is the situation. So you know, oh, this is the refracted refraction experiment, okay. So now the inference, okay, I think I give you already, right, the experiment. Okay, I ask you just to remember that, okay, and that's okay. Let's say, but for those who didn't get, because maybe on Thursday you didn't come, but I was already leave to your friends, okay, to give it to you on Friday, okay. So inference, they must have the word depend, okay. So teacher, depend what? Okay, so your RV depend on MV, okay. So responding variable. So what is your responding variable here? So responding variable is your refracted angle, right? In the experiment just now we discussed your responding. So your refracted angles or angle of refraction depend on the angle of incidence. Must have the word depend. So angle of refraction depend on angle of incidence. Okay, this one I think you can see in the schema also they already give to you. Some put depend, some put influence. Okay, can use the word influence also. Yeah, I just show you the affected also can, as long as the same meaning. Okay. All right. So next hypothesis. Okay, when they mention about the hypothesis, this is the one that you answer like the one you answer in paper 2, the relationship, remember? So the higher the angle of incidence, the higher that is the how to answer the hypothesis. So if you look at the schema here, they given to you, say the larger the angle of incidence, the larger the angle of refraction. You can put this one, or you can put the higher the angle of incidence, the higher the angle of refraction. Teacher, can I put directly proportional? No, cannot. Why? Because directly proportional in paper 3 is only used to describe the relationship of graph. Okay. But teacher in paper 2 can, yes. Who is it? Greater laser? Greater laser, yes, can. Greater laser can. Okay. All right. So this one cannot use directly proportional. Okay, directly proportional is only for the relationship of the graph for the paper 3 for the Amadi. All right. Okay. Then after that, apparatus. Teacher, you have to draw. Yes, you have to draw. Okay. And okay, we already answered this one. Okay. You have to draw the apparatus. Okay. So in the answer they give you how to draw. But in our experiment, you replace the ray bulbs with laser. So we don't have the menthol, all that we don't have. Okay. So you just replace the laser. Okay. This one. Okay. Now teacher, when you draw, do we need to label it? Yes, you need to label. See, must label the ray box. So ray box mean you label it with laser. Okay. Laser, glass block, and I and R also you need to show. But this one they use they use a block, right? But we are the one that we use is semicircular. Okay, so you need to show where is your I and where is your R. Okay, that's why I said they will ask you to submit your A4 because this is the reason. Okay, so this is your arrangement of apparatus. Okay, now this is the harder part. Why I said it's harder part? Because you need to put the procedure. How do we do the experiment? Okay, so we already have the arrangement of apparatus. The procedure which includes one method of controlling the manipulated variable and measuring the responding variable. So how do we control? The manipulated variable here is what? Is incident, angle of incident, right? The responding variable here is what? Is the angle of refraction. So how do we control that? How do we control that? So you see here they state, trace the outline on the glass block and the white paper. So you describe what is the first thing you do. Okay, so you put the glass block there, right? The semicircular. Then you draw, right? The glass block. Yes. Teacher, the white paper, can I use the box provided as the white paper? Teacher, can you send? Yeah, I will send it later. The white paper, can I use the box provided as the white paper? Oh, you mean this one, is it? Uh, Which one, Yang?
Teacher, the drawing. Yeah, this one.
You have to draw it like
Can I?
this.
Do I need to like draw another white paper, like another column to like to represent the white paper, or can I directly use the box provided?
You have to draw like I draw now.
Draw another white paper at the.
Yes, you have to know that.
Oh,
All
okay.
the diagram must be inside the box.
Oh, okay.
Okay.
Thank you, teacher.
All right. No need, no need. Draw. No. Because all the diagram must be inside the box. Okay. Must be inside the box. Okay. So you copy down. This is my example lah. Because this one if you do use the rectangle block. Okay. So this is the I. Okay. Then you see this is your R. So you label lah I R. Okay. And then this is your ray box. This is your glass block. Okay. You label like that. Okay. Then another part they ask you. Okay. I go to the this one. So trace the outline. So you put all the things that you do. Okay, but no need lah to put switch because we don't use the ray box. So we don't use the ray box. So you are lucky they don't have the word switch on. If they use the ray box, actually they have to put switch on the switch on the switch off the switch first, right? Because if then how you can get the ray box to light up? Okay, so this one we use a glass, we use a laser, so don't need to put that one. So trace the outline of the glass block on the white paper and draw a normal line. See, you have to state, you draw a normal line. Okay, at point O. Okay, then you direct the light ray from the ray box at angle of I 10 degrees using the protector. Must take, okay, you must take the angle here and you use what to measure the angle. This is what they said. Okay, this is what they said. How you control the manipulator. How do you control it? You use a protector. Okay, you measure 10 degrees. Okay, so that's how you control your manipulated. By using the protector, you measure the manipulated variable. Okay, then remove the glass block and draw the refracted ray. So OP, come like this. Okay, then after that, you have to measure the responding variable. So the responding variable is the angle of refraction. So how do you measure the refracted angle? You use protractor and record the reading. Must have the record the readings. Okay, must have the word. Whether if let's say anything that same meaning as the you try to record, let's say write the reading. Okay, put it in the table. So all means all the same meaning, right? Mean you record. So you can get 1 mark. Okay, so measure the angle of refraction R using a protector and write it on the table. 1 mark. Same meaning as the record. Okay, or record the reading. Also you can get 1 mark. Okay, so means you need to do step by step. Okay, tak payahlah cakap you letak paper atas meja tu, tak payahlah kan. So it's just pergi terus. Okay, you just put, okay, you put the glass block, you put the trace here. Okay, you say draw the outline for the glass block. Okay, don't need to use the same center also can, but as long the meaning is same. Alright. Okay. After that, alright, we already done. And the next part, okay, repeat the experiment. That's the important part. Repeat the experiment, okay, at least 4 times. Okay, 4 times. 3 times I think is, 4 times mean not the same reading. 10, 10, 4 times, no. Okay, means this one is not repeat. Actually, repeat the experiment. No need to put this one. Okay, repeat the experiment by using, okay, repeat the experiment by using I 20, 30, 40, 50. You got 1 mark already. The minimum reading must have 5 readings. So you already got 4 here, right? Then you add 1 more 10 degrees here. So you got 5. That is the minimum. Teacher, if I want to do 8 reading, it's up to you. Okay? Teacher, if I want to do, tapi in your experiment also you have to do 8 lah. You have to do 8 reading also. Okay? So just put 5. 5 is the minimum, right? I is 10, 20, 30, 40, 50. Teacher, can I put any value? Okay. So for me, my advice is choose 10, 20, 30, 40, 50. It's okay. Or you can use 20, 30, 40, 50, 60. it's okay. But for me, it's better safe you put 10, 20 because the range is increasing, increasing uniformly. Okay. So you put 10 the minimum, don't put until 100, okay? Then your graph will become, it's hard for you. The angle of the reflection later will become so big. Okay. So you put here like this, at least 5, remember? Repeat the experiment by using angle of incidence I 20, 30, 40 and 50. 1 mark. So total for the procedure here, right? So let's see what's the mark for the procedure here. Is 3 marks. Okay. So first one, use how do you measure the manipulated variable. Okay. So you draw the outline for the glass block. Okay. And then you make sure that you put the angle of incidence. Okay. It's 90 degrees from the, it's an 90 degrees of the normal line, right? So you just, and then say use protector, must have use protector. Then second one, measure the angle of refraction by using the protector. Okay, and the last one, repeat the experiment with the I is equals to 20, 30, 40, 50. Okay, don't put more than 5. All right, so the next part, okay, we already done until that. Okay, so record. This one is the same as the one that we do. Okay, so you can see here, all right, you have to do the experiment also. Not just write the procedure, draw, no. You have to do the experiment, you have to draw the graph. Sometimes mungkin ada dari sekolah lain ni tak apalah, kita kongsi ilmu kan. So maybe tak apa kalau tu saya mungkin doa anak murid saya and okay, I pray maybe if I've helped someone then others will help my student also. Okay, so we just share, okay, we just share our knowledge. Okay, then record the R, sin I and SAR R here. Okay, this one is the same like I teach you before. Okay, you do have to do the experiment. So you can see there is set 1 and set 2. Okay, because it's depend on your eye. If you use eye is 10, 20, 30, then you got this one. This is the reading. Okay, so you see they pick 4 decimal point. But for me, 3 or 4 enough. No need to put until 4. It's too many, right? Too many. Later then you have to round off also. So it's no point. So set 2, they put this one. If the student give 5, 10, 50. Okay. So you can see they didn't put until 20, 40, 100. No. Okay. It's between the largest is 50. Okay. So this one already teach you. See, this is how we mark the paper. Okay. Have to be label. Alright. I put the one label. Okay. Must have label. Okay. No unit, uniform scale. So you plot it correctly, 2 marks. Okay. Let's say you plot it 5 points. You put correct all 5 points. Then you got 2 marks. Let's say you correct it on, let's say 5 points, you only 3 to 4 points correct. So 1 mark. Okay. So this one, if you plot it correctly, 5 points, so you get 2 marks. Okay. And best fit line means the line 2, 1 or 1, 2, 1, 1. The one that I teach you, the size of graph is more 5 times 5 from the origin. So you can see my graph. Is my graph. Oh, no, it's here, right? Yeah, my graph. So of course this one more lah. Okay, so that's why I said to you, try to draw the bigger one. But make sure the scale is enough. Okay, so don't need to put, teacher must have at least 1 box. No, see, I use the outside one, the line outside. Because I want my graph to be big. Okay, then later it's easy for me to plot to find the gradient and so on. Okay. All right. So after that, you just doing the same thing. Put this, see, they put a tabulate your data means yes. Teacher, the refractor rate that we measured to be the same with the schema or can be different. Okay. So last year when I'm marking, right, they already give a range. Okay, they give you a range. So let's say macam tahun lepas, bacaan dia mesti, that's one because they did the internal resistance. Okay, last year experiment is an internal resistance. So they already put okay, the value of E, right? E is actually the internal resistance, right? The intersection of Y axis. Okay, they give you the value already. So they give you range. So you don't worry. You just do the experiment. Okay, you just do the experiment, do it you know the step they given. If don't have mean you are I already give you how to do it, right? In the paper I give, in here also they ask you they teach you how to draw. Okay, and also you have done your amali then practice already. So you just put down, but the value you don't worry because okay there will be a range. It's not like specific has to be there. So don't compare your answer with your friends. Okay, don't compare. Maybe your friend got 0.4, you got 0.5, still in the range. But let's say your friend got 0.4, you got 0.1, then must be something. Because it cannot be like too big value. Teacher is the trend, but do we have to see refreshing? Okay, wait, I read the question first. Refreshing index of glass, yes, around 1.5. That is the theory one. But we don't know our glass, our semicircular glass block. What is the index of refraction? Okay, the one that that one is the theory, correct. But the one that we use, we need to find it because not all glass have the same refractive index. Okay, they didn't provide us, mean they didn't ask us to use the same one. Mean it have to be tengoklah pada supplier, okay, what type of the refractive. So I said 1.5 is a theoretically betul, but you need to find on your own because all we have different kind. Yes, correct, we can. Teacher is the protector provided. Yes, we given you the protector. You just need to bring your ruler. Two ruler, okay? The long one and the short one. The long one is for the graph. The short one is to draw the reflected. Right? It's hard for you if you use the long one, okay? So any question you can just put in the chat. I will read later. Okay, this is the same. Okay, sine r against sine I. So sine r will be the y-axis, sine I will be x-axis. Okay, then the relationship. Remember, don't use the higher the angle of incident, or the higher the sine I, the higher the sine r. Okay, okay, no, please don't. Okay, that's why bila saya ajar kan, paper 2, I will not allow you to do the directly proportional. Why? Because later you will be confused. Later in the paper 3 also you put that like that for the relationship. No, okay. So for me, just specify like this. Is paper 2, okay, when they ask you relationship, the higher that one. Okay. But paper 3, when they ask you the relationship of the graph, directly proportional. Don't use, because if you put the same thing, then later you'll be confused. Because on paper 2, you can put both, right? The higher the angle, the higher the R. Or you can put directly proportional. In paper 2 can. But in paper 3, no. Okay? In paper 3, if you put the higher, that one is hypothesis. Okay? So, but for the relationship of the graph, directly proportional, increasing linearly, okay? That's the only two, okay, for this experiment that can be acceptable. Don't use the higher, okay. When I marking like I think in the trial there's quite a lot of you answer like that, so it's very already I see so many time no, right. So jangan buat kesilapan yang sama lah kan, sebab ini dah tak boleh nak buat apa dah kan. Saya tak tanda pun kertas awak. So predict. They ask you to predict what happened to the gradient if the glass block is replaced with the perspex block of the lower optical density. Okay, actually the index of refraction, it represent the density of the glass. Okay, it represent the density of the glass. The higher the index of refraction, the higher the density of the glass. Okay, so now they said they use the low density. So what will happen to the gradient? The gradient represent what? The gradient represent the index of refraction. So what will happen to the index of the refraction? It will become lower, right? So your gradient also will become lower lah, because your gradient represent the index of refraction. Okay, so that's this. Yes, I scared the teacher not apa tu macam ni. Okay. Can we bring spare protector? Yes, you can. You can. Any you know, like stationery you can bring. Teacher, what's the operational for physics we don't have operational definition. It's only for chemistry. Physics we don't have operational definition. If they ask the operational definition, just give the meaning of index of refraction. Sin I divided by sin R. That is the operational definition. Okay. Better bring your own ruler protector, safe side. Yes. Good. Yeah, better bring on your own. I scared the teacher not allow. Yeah, we allow because there is a stationery. Okay. Jangan bawa jawapan je. Jangan you bawa kertas, you bawa tu tak boleh. So that one cannot be allowed. Because later your A4 paper that the one that you draw, if let's say you don't submit, if let's say they don't ask you to submit that one, it will still be collected by the pengawas. Okay? By the pengawas, they will be collected and then we throw away. Because you cannot go out, bring out any paper from the dewan. Okay? So kalau ada, because last year ada. So you jangan bawa keluar apa-apa. Macam mana apa yang you bawa masuk dalam, itulah yang you bawa keluar. Jangan bawa balik kertas soalan, jangan bawa balik kertas A4. Let's say they give you extra, the one they say you don't want to use again, maybe silap apa, just leave it there. Don't bring out any paper. Okay, later sekarang you discharge pula macam-macam kan. Ni SPM bukan kat sekolah tau. Kat sekolah cikgu bagi je kan, timbal-timbal balik bagilah markah. So any question you want to ask? Okay, this is the unguided one. So for those yang nak, you want the paper 3, this one, the schema for 5E. I'm sorry, 5E. Ada tak 5E kat sini? Is there any 5E class here? If got, okay. So if you are from 5E, can you like text me because I lupa nak bagi yang paper 3 ni kan. Do you have my number? You ask lah the student, okay, inside the other class, ask for my phone number, I will give it to you. Then later you just put in your group, okay. This one is okay because this is yang guided one. Saya dapat pun baru tadi. Give one people, he sent, yes, give one people. Okay. So okay, I put lah my number here. Let's say kalau nak tanya apa-apa, I'm okay. Tapi don't ask me after 12. Okay, saya sampai pukul 12 je saya layan. Lepas tu saya tak layan dah. Okay, anything? Okay, before, okay, jangan takut, tolong jangan gelabah, jangan nervous kan. Teacher, I'm so nervous, teacher, I'm so scared. No need. It's just like what you doing in the school, okay? You already done right. Just be calm, slowly, okay? 45 minutes, is it? Kan? So any questions sebelum saya stop? Gradient can 3 decimal place? Yes. 2 until 4 can. One cannot. But lucky this experiment we don't have unit. So tak apa. Tapi kalau let's say yang lain tiba-tiba terkeluar soalan lain, awak tengok ada unit, they say if they have a unit, put a unit there. Okay. How to find the unit? The y axis unit divide by the x axis unit. Ada? Ada question? Ada questions nak tanya? Ada. Okay, so later kalau ada apa-apa boleh je WhatsApp saya. Alright, so terima kasih semua. Thank you very much, okay? Alright, so I see you tomorrow. Good luck for everyone. Okay, good luck for everyone. Take care everyone, okay? Remember, come early.
Okay, teacher.
Yes, come early tomorrow, okay? Yeah, you can text me.
Thank you, teacher.
Yes.
Bye-bye.
Thank you. Bye-bye.
Thank you, teacher.
Okay, welcome. Okay, welcome. Okay, welcome.
Teacher,
Yes.
can you open the slide of the place increase linearly?
Which one? Oh, wait. You mean the for the MRSM one or the one that I draw? My graph, is it? This one.
The top one, the writing one.
Which one? Okay, this is mine. The MRSM one, is it?
Yeah.
Oh, the MRSM one.
If
There's no graph here.
can you see the question, not the graph question?
Okay, this one.
Top leader.
This one.
Top one.
The top one. Is it? Which one?
bottom later. Sorry.
Bottom, okay. You tell me when to stop, okay? This one? No. No. Or maybe the one that we discussed or here.
The first question one. The first
The
question.
first question one. Is it this one? This is the first question that we discussed.
Bottom later.
Button little, okay. This
Stop,
one.
stop.
See here.
Tablet. Yeah.
Okay.
If we write increases, is it okay to increases?
Increases cannot, must be increasing linearly.
Oh, why is it mean increasing linearly?
Increasing linearly means okay. Wait, I explain to you. Okay, so you learn in form 4, right? In physics you have two types of graph if the graph is increasing. The first one is a directly proportional. Okay? And the second one is like this. Whether here is not passed through the origin. This we call it as increasing linearly. Because the graph increase linearly, like in the straight line. So that's why we put it increasing linearly. Can you understand?
If tomorrow as I ask this question, state the relation between sin I and CR, if we just write increasing linearly, is it correct or there's other
Okay,
answer?
that one have to be depend on your graph. If your graph you get like me, okay, mine is not passed through the I erase it. Okay, mine you can see it's not passed through the origin, right?
Yeah.
So this one is increasing linearly. But if your
Oh.
graph, you have to see the graph you draw. That's why the question asks based on your graph. So you mean you see your graph. What type of graph you produce? Okay.
Oh, okay.
So this one because my graph cut off x-axis. So I cannot put directly proportional. I have to put increasing linearly. If my graph between one small box, you can see one small box here, right? Okay, you got like this. Let's say it's not passed through directly, but it's still in one small box there. That one we call it directly proportional. Okay, only two answer can be acceptable if this question come out. Increasing linearly, directly proportional. Other than that, cannot. Don't put the higher to cannot.
Teacher, can you repeat what is directly proportional?
Directly proportional must pass through the origin. This one. This one. This is a directly proportional. Okay?
Oh, okay.
So let's say it's not pass through the origin 0, 0. Means you have to put it direct, increasing linearly. Okay?
Oh, okay.
Alright.
Okay, thank you, teacher.
Welcome. Okay. Others question? I see some of you. Yeah. Wait. I still ask. So far, no. Alright. Thank you. If you have any question, you have my number. Okay?
Teacher,
Yes.
I got one
Saji.
question, but it's a complex question. So,
Complex
yeah,
question.
but can I send you the picture? And then you answer me
Yeah.
through the Google Meet.
Yeah. Sure. Sure.
And so,
Is it according to the tomorrow question?
yeah,
Tomorrow?
tomorrow's
Okay.
one.
Oh, you use.
But I just send you the picture through WhatsApp because
Okay, wait. I open it. Okay. So it said what? Okay, I saw the picture.
okay, and then yeah,
The
this is a
blue,
question.
the red one, yeah. Okay.
Yeah, this is a question.
Oh, so mean you ask me whether you need to follow the green one, the red one, or the blue one, is it?
No, what I meant was like they say from the one that we did experiment, right? The teacher told us that draw the line from the plot, which is the green arrow, to the surface first. That is the red arrow.
Mm-hmm.
From the red arrow, which is the surface, you connect it to the normal. But then from the video that you suggested to us, it directly connect from the plot to the normal. So
Okay,
which one is it?
so let's see the video. This is the video, right? Oh no. Okay, you mean like this one? Okay. Mm-hmm.
Uh, which video?
Fast forward it first. Okay. You mean it like this, is it?
I can't see any video.
Yeah. We just fast forward. Oh, so your teacher asks you to draw from here. Means this one from outside, then another one from the glass block. So that's why you cannot get the straight line, is it?
No,
My guess, my advice is follow this teacher because he's the one like he's the one that for me lah, he's like very the one do in front of you, right? So just follow this one. Because I see when you draw also, sometimes your line is not straight, right? If I'm not mistaken, when I see your paper, right? Your line here is like there's another reflected ray. Right. There's another because here, okay, then it's refracted. Okay, then it will be refracted again. So your line is not like a straight line like that. It's like
yeah,
refracted two times.
two
Right? It's
twice.
refracted two times. Yeah. So just follow this teacher. Okay. Just follow the light way. Okay. So follow
The
that one.
teacher from the video, right?
Yeah, the teacher from
So
the
which
video.
means I draw the line from the plot straight away to the normal. No need to draw
Yeah.
twice.
No need. If not, then you get like two times reflection because when you come out from the glass, one time more reflection. Am I
Yeah,
right?
one more.
Yeah. Yeah. Okay.
Uh,
Just follow the teacher.
yeah, and then
The
teacher,
mm-hmm.
when you draw the graph, you got exactly 1.5. Is it as refractive index?
I draw the graph means you
Yeah,
find the
when
gradient, is it?
yeah your graph, and I saw the answer, you got 1.5 exactly. The
Oh,
teacher, yeah,
yeah, this one is it?
yeah.
Okay.
Uh, Teacher got it exactly, is it? Because I thought very hard to get 1.5.
Yeah. This one is actually because the reading is already given by the question.
Oh yeah.
Yeah. Before it's Amali means you have to do on your own. This is the paper that you have to answer. No need to do the Amali one. So they give you the value, you just stay and then answer. Then no experiment. But now you have to do the experiment. So that's why it's different. And of course, there will be different because 1.5 is like I see just now. We don't know the semicircular glass block, right? Some not like 1.5. It different depend on the material. Okay, depend on the material.
Yeah, and then one more, teacher.
Yes.
The triangle, right, for the gradient, must I put a straight line or dotted lines?
Okay. For me, better put the straight line because if dotted, later when they scan your answer, you cannot see it clearly.
Okay.
Put the line.
Uh,
The
the
darker, the better.
the same goes for the interpolation, right? When you want.
Yeah. Make sure when they want to mark your paper, you can see your paper. Mean you can see the triangle. There's a triangle here because sometimes the line. I think in your line they use a blue one, right? The blue one, but then later when they scan, the blue will turn to black. So make sure like that's why I said you put I forgot to mention just now. Put the coordinate. So they know that you take the triangle there. So you see the one that I put, they say this one, right? This is the example. So put the coordinate here. So the teacher know that actually you draw a triangle and you choose these two unit. Okay,
Okay.
put the coordinate. Okay, alright.
Yeah, done, teacher. Bye.
Alright, bye. Any others?
Teacher,
Yes,
if
yes.
we calculate the result, can we round off the decimal number to 1 or 2?
Okay. No, one cannot because if they say your calculator calculate exactly 0.5, okay,
Ah,
then you can put 0.5. But if your calculator give you more than the long number, then you have to round it off to two until 4 decimal point.
2 decimal. Also
Uh,
2 decimal point.
Two or four. That's the highest lah, four. But remember, are you from from which school? Eskopong Baru School, is it?
Yeah.
Okay. You're 5A.
Yeah.
That's why I didn't read apa family name. Okay. This one. This is you need to be very careful. Even when you put sign I, you got 0.5, right? But
Ah,
like I said, in the table, the decimal point must be uniform. Okay. So you can see even you calculate it, you got 0.5. But since we take 3 decimal point, so this one also have to be 3 decimal point. In the table only. In the table. But later, if you use a calculator to calculate the gradient like this, right? The gradient, yeah, you have to take 2 or 3 decimal point. Are you clear?
Clear, teacher.
Alright, okay.
So in the tabular data, we have to put our answer in 2 decimal point or 3 decimal point, right?
Okay. For this one, if angle, sine I must be 3 decimal point or 4. Okay, 3 decimal point or 4.
Okay, thank you, teacher.
Okay, let's become. Okay, any other questions?
Yeah, teacher, the procedures, right?
Yeah.
Can I use the procedures from the set 3 that was given to us?
Yes, can.
Yeah, done.
Yeah, okay. Others? No. Okay. So anything, just text me. Okay. So see you tomorrow. Take care, everyone. Okay. Bye. Which mean in table we use 3 or which mean in table we use 3 or 4 decimal point, in graph use 2. Wait. Which mean in the table we use 3, in graph use 2. Okay. In table, yeah, correct. Betul. Later because in you it's hard for you to plot 3 or 4 decimal point in the graph, kan? So you take 2 only when you draw. But in table 3 or 4.
So teacher, in table we write 3 or 4 decimal point, but in graph we write out to 2 decimal point.
Yes, correct.
Oh, okay.
Okay.
Thank you, teacher.
Okay, welcome.